Okay. Now for each problem that we do, this is going to be the same process to solve your implicit problems. So in order to do implicit differentiation, we have to differentiate both sides of the equation with respect to x, collect the terms with dy dx on one side of the equation, factor out your dy dx, and then solve for dy dx. So again, as long as you're doing it the way that the book is showing you how to do it, this is the exact same process for each problem. So in order to make this a little bit more applicable, we can apply this concept to like a lens, and that could be like a contact lens or something optical or anything like that. So in the law that describes how light changes direction as it enters a lens, the important angles are the angles the light makes with the line perpendicular to the surface of the lens at the point of entry. That is called the normal to the surface at the point of entry. In a profile view of a lens, the normal is a line perpendicular to the tangent to profile curve at the point of entry. Okay, so when a line enters in, or when light enters into a lens, you have your tangent line to the lens and then your normal line to the lens. So that normal line is how light will reflect off of the lens at that angle. You can see that little diagram right down there. So let's take a look at a problem like this. So we have a pretty nasty equation. So this is a little bit more complex. But again, I'm just going to use that little guideline or that process to help me out as I'm going. So I need to find the tangent and the normal to the ellipse, which would be like a lens, at this point. So don't forget about that point. So if I'm differentiating with respect to x, I'm going to start out, so that's going to give me 2x minus, now we have to use the product rule, so we have that xy, so that's going to be first times derivative of the second, which is just going to give me a dy dx, plus the second times the derivative of the first, which will be a -1, plus 2y dy dx equals 0. Okay, now again we have to get all of our dy dx's onto one side. So I'm going to get rid of this 2x, and then this is going to be a -y, so I'm going to say plus y on both sides. And then I'll also just switch that around, so I have y minus 2x. Alrighty, so we have -x dy dx plus 2y dy dx is equal to y minus 2x. Now, next step in that process is to factor. So we want to take both dy dx's out, and then we're going to be left with, I'm going to switch those two things around, so I have 2y minus x equals y minus 2x. Last step is to get dy dx by itself. Okay. So from here, since we have dy dx all alone, we can plug in that -1, 2. So that's going to be equal to 2 minus 2 times -1 all over 2 times 2 minus -1. So on the top, we're going to get -1 times 2 is going to be -2. That's going to turn this into a 4. And then we're going to get 2 times 2 is 4, minus -1 is 5. So that would be our tangent. So the tangent equation at that specific point, I guess we can just go the one step further. That would be y minus 2 equals 4/5 x plus 1. And remember, you can leave your equation like that. They will accept that on the AP test. So that's our tangent. Now the normal It's perpendicular to that tangent line, so we will have a slope that is opposite reciprocal, so that'll be negative 5 over 4. And then we're using that same point, so that'd be y minus 2 equals negative 5 over 4, x plus 1. And that's it.